Hi guys, I've got a setup I want to show you. This is my two motors, Y1 and Y2. I've got a foot switch down here. So if you tap it, the two motors will run into position. And it goes back up, simulating the beam going back up. So I just did a bend which represents a 45-degree bend with a depth of target of 0.74 millimeters into the V, as you can see there. So I've got our normal amplifier. So it puts out a Y1, Y2 signal, which I run through a forward reverse relay. And I've got a foot switch input into the PLC with the encoders input to the PLC. I've got three signals out. On the left, the green is Y1 PWM, then Y2 PWM, and then the direction signal, which is OR in the PLC, so it's just an enable signal in this case. The second signal, the purple wire, is switching my forward reverse relay. So let's look at a few bends. The 45, I'll just do one again. I'm going to hit the foot switch. Into slow, so I'm going to ramp down to the bend speed. And then I've got automatic return set up on the Fasfold controller, so it'll automatic return after it's completed the bend. I will just do another one, but go back up. And for this next one, I'll go into settings. Go to the Y-axis. So I've got the fast speed set at 80%. I've got the slow speed at 2 milliseconds. I had to play around with these figures to make it work properly on these two little motors. The bend speed I've gone on 1 millisecond, and there's my slow distance, and the ramp and the bend distance is 1 millimeter. There's my gain and my two actual positions. I'm using on this rotary encoder, I'm using a cal factor of 5. We normally have for all the linear slides 50. They're all standard. So you can look at the analogs. So if I do another bend, although I don't use analog signals here, in Fasfold it doesn't know about PWM. It only knows about the percentage from 0 to 10 for the signal. Let's do another one. Okay, let's put another job in with 3 bends. Got a quick draw. Let's put a 90 and a 45 and a very small angle, the next one. And I'll change that to 0.1, which is we'll just pinch the material. So we've got 3 targets for the 90 degree, 3.68 millimeters below the top of the die, 1.42 for the 45 into the V, and this bend, because it's only pinching the material, it's not really going to bend it. The target is minus 2 millimeters. That means 2 millimeters above the die, because I've got 2 millimeters material thickness selected, so the target is 2. So this is the target that come from the PC into the PLC or the controller. So now I have to press start, and for this one I'm going to switch the automatic return off, and I'm going to do the first bend, which is the 90. Alright, so they stopped. On the clock it looks like in sync, and the actuals is 3.71, 3.71. And my target was 3.68, so there's a bit of a difference there. I don't know why. And now to return this, I have to simulate my foot switch up signal with this wire. I don't have another foot switch. If I press up, it'll ramp up. So I'm going to do the next bend, which is now moved to bend number 2. So the target will be 142. And they're both sitting at about 25 past the hour. And I've got 145, 144, target is 142. By the way, I've got good results with this power for the motors on 9 volts. If it's on 24, it just runs away. I can't control it. So let's go back up. And it's going to do the third bend, and the target is minus 1.99 for the y-axis. If I stop the one, the other one stopped, and their positions is 0.35 millimeter difference. The analogs, of course, on this one I'm holding would be 10 volts at this stage. I'm not on that screen, so I can't show you. And if I let go, I haven't got my gain set properly, so it lost a bit of control there. It was a bit jumpy, but it finally stopped at 197 and 192 negative with a target of 199. So I'm going to turn the automatic return on, and it's returning, and the top position is set at minus 30, so it stopped at minus 32 and minus 32, so there's a 2 mil overshoot. It doesn't try to position it when it goes up, it just waits till they're both on 30 and then it switches the valve off, which is not a problem. So this is going to auto return. It's now ramping down. So I want to show you the analogs when I interrupt the movement. From this screen I'll go to the diagnostic screen. It's better to see. Don't know why it's not very responsive at the moment. There we go. So by the way, the dashboard screen shows inputs on the left, like foot switch and that. So if I tap the up foot switch, it's not, there we go. I don't know why it's a bit slow to respond. It shows it's on at the moment, but it's not. Ah, there you go, off. The comms is maybe hanging up for some reason. There we go. So if I go up, you can see the analogs. You can also see the Y1 and Y2 actual positions, 41.5, 41.4. This is the conventional valve outputs, not the proportionals. So if I go, I'm not using the conventional valves at the moment, of course, because they are very straightforward. So I'll show you what the analogs does when I interrupt the movement. So let's do another bend. So I've got the one sitting on 8 volts and the other one on 0, and 38.1 and 38.4, and it's really trying very hard to release my grip. So it's a lot of miscontrol there, but if I set the right settings on the PID loop, I'm pretty sure I can get that running smoothly. So coming back to the amp, I've got Y1 PWM from the PLC, Y2. I've put them on pull-up resistors because our pull-ups is removed from the board, the service mounts, because they were getting a bit hot. And then that third green wire is the enable at the moment. Normally it's an up and a down signal, but I'm just using an enable. And then this is the Y1 PWM out amplified, this one, and this is Y2. And then they run through this relay, which just switches the polarity to the motor. So I think I'm going to just ship you this test jig as it is, or maybe modify it a little bit, but I think it's a good test jig.